What are isotopes? Isotopes are atoms of the same element with the same number of protons and therefore electrons, but a different number of neutrons. Here are some examples. Carbon 12, carbon 13, carbon 14. They're still all carbon, they're all the same element with the same number of protons, 6, but a different number of neutrons and therefore different mass numbers. Here is another example of nitrogen. These are the isotopes nitrogen 14, nitrogen 15 and nitrogen 16. They all have the same number of protons, 7. That's what makes them nitrogen. But they have a different number of neutrons and therefore they have different mass numbers. Now, what is relative atomic mass? This is the average mass of atoms of a specific element taking into account the mass and abundance of each isotope. So it's like an average number taking into account the masses of the isotopes and their abundances. We're going to work out the relative atomic mass of chlorine, taking into account its isotopes, chlorine 35, chlorine 37. This is the equation we use to work out the relative atomic mass. We do abundance of isotope 1 multiplied by the mass, or mass number, plus the percentage abundance of isotope 2 multiplied by its mass number, and this continues if you have more than 2 isotopes. We divide this by the total percentage 100. Let's look at an example. In a sample of chlorine, 25% is chlorine 37 and the rest 75% is chlorine 35. Calculate the relative atomic mass of chlorine. So chlorine 35, chlorine 37, the mass numbers are given to you, 35 and 37. The abundances are also given to us, 75% chlorine 35, 25% chlorine 37. So we put the numbers into the equation, percentage abundance multiply mass number, percentage abundance of isotope 2 multiplied by mass number. We divide it by 100% and we should get 35.5. This is the relative atomic mass of chlorine, and that's what you see on the periodic table. The bigger number on the periodic table is the relative atomic mass. It takes into account all of the isotopes for that element, and this is why it's a decimal. Here's a question for you to try. Read the question in the box and use the equation to work out the relative atomic mass of rubidium. Pause the video now. So, in a sample of rubidium, 72% is rubidium 85 and 28% is rubidium 87. Calculate the relative atomic mass of rubidium. So we have the mass numbers given to us, 85 and 87, and their abundances, their percentage abundances are given to us. So we multiply the mass number by the percentage abundance, and we do the same for the isotope 2. We add those numbers and divide it by 100, and we should get 85.6.